Hi, I'm Jonathan Cast, and this is Global Scripts. So today's topic is what is a monad? Not explicitly going to address why monads in this video. Hopefully I'll do a follow-up video on that topic. But I want to go through what is a monad first. So hopefully if you understand that, then the question of why monads is going to make more sense. So I'm going to approach this from the assumption that you're a programmer who's new to global scripts and you've encountered this, okay, you need monads to do I/O in global scripts. And the question is, or maybe you're a programmer who's new to Haskell and you've had the concept, okay, you need monads to do I/O in Haskell, and you want to know, okay, what the heck is this weird concept that I need to understand? But I'm going to address it from a global script perspective. So what is a monad? Basically, so I do want to back up and give you a little bit of context here. So we'll look at two expressions just to get started. And again, this is global script code. I think you'll be able to see this. Hopefully you'll be able to see what I'm writing. So this is some arbitrary global script based language. You don't need to worry about the details too much. So this is one expression, print hello world. And then your other expression is just an empty record literal. Let me make that a little bit bigger. So what you might expect if you have some exposure to other languages might kind of make sense that the print function is going to return the empty record because it basically doesn't have any real status or result to return. So you might say, okay, print an empty record. Well, print has the value empty record or returns the value empty record, but you can't really say that these are equal. Right, because you can't, if you have empty record, you can't replace it with print hello world. And if you have print hello world, you can't replace it with the empty record. So you can't say that these two expressions are equal. So again, I'm not going to go into a ton of details in this video about why, but in global script we take that a step further and we say that not only are these two expressions not equal, but we actually give them separate types. So we give this expression a type empty record. And we give the empty record just the type empty record. And so this type constructor is the first component of a monad, right? So a monad is a three-tuple. It's a tuple of three things. One is a type constructor, which we're just going to call M, some arbitrary type constructor. So in global script, we have a bunch of examples of this. We have IBIO.m for the IBIO programming language. We have chord.m. We have GSIO.m. We have GSI.m, and so on. So there's one of these for each programming language. Basically, for each sort of procedural programming language based on global script, there's a type constructor M. And so for the purposes of this video, where we're just explaining what the heck is this thing that I need to understand to do I/O, we're going to say that M is a type constructor where a type application, M alpha, is the type of subprograms that return this type to the program. So we've got some examples, example operations, right? We've got print takes a string, you don't really need to worry about this. This is just a string type, and returns a subprogram that returns the empty record. getLine is a subprogram that returns a string, and so on. So a subprogram is obviously a different thing from the value that it returns. And if your language is based on monadic I/O, it has a different type. There's a type of the values that it returns, and there's a type of the subprograms that return those values. So that's the first component of a monad. The second component, again, being very practical, each of these programming languages, essentially, you could think of as having a language construct of this form. So here, E0 is some subprogram expression, towards some type alpha, or let's call it T0. X is a variable that's defined by this construct, so it's in scope here. X is a variable that has type T0, so X represents the return value of E0. E1 has type MT1, so some other type. But you can use X inside of E1. So this construct is the answer to the question that comes up in pretty much any Haskell newbie forum. I have an I/O string, I need a string, what do I do? Well, you say in global script, you say for X comes from, and then you put your I/O string, and then here, X is your string, and you can do whatever you need to with it. So then the reason E1 needs to have this type is because this whole expression has the same type as E1. And so this whole expression, in order to get the value returned by E0, in general you need to run E0 to figure out, okay, what's the value returned by E0? And in order to do that, you need to yourself be a subprogram in this language. So the whole thing has to have type M something. It has to be a subprogram. And we want this for construct to always have the same type as its body. So we say the body has to have type MT1. And then the third thing is you have a function, unit, which takes, now I'll use alpha, alpha to M alpha. So this gives you the simplest possible subprogram where if you say unit x has type m tau if x is some variable of type tau. This, unit x, is the simplest possible subprogram that has x as a return value. It doesn't do any I/O. It takes as little time as it's possible for a subprogram to take, and it returns x. So obviously, if we've got this special type of subprograms, we've got a function that takes a return value. We need this construct to be able to use the return value. And then this is the dual. This is the dual of this construct. We've got a return value, but we need a subprogram. For example, we're the body of a 4. We need to be a subprogram, but maybe the only thing we're going to do is return some value that we calculated using x. What do? Well, we call unit, give it the value we want to return, let unit handle it. So for this reason, by the way, those of you who are interested in Haskell, this is why Haskell calls unit return, because the expectation is that return is only ever going to be used right here, where it functions like a return keyword from other languages. If you use return anywhere else, it doesn't function like you're expecting a return keyword to do from other languages, so it's kind of a confusing name. But as long as you stick to the idiom of only using it here, it kind of makes sense. So this is basically all that a monad is. It's a separate type for programs, so we can keep programs and values separate. It's basically 2 language constructs for getting the return value of a program and making a trivial program with a particular return value. Obviously, this is not useful unless you've got operations like print or getLine, or Chord has operations like select, GSI has operations like eval, that do something interesting inside this language. But those are features of a particular monad. The thing that makes a particular type of subprograms an example of a monad is that it has these 3 properties. So that's the definition. What is a monad? This is Global Script. I'm Jonathan Cass, and I'm signing off.